Water is neutral and has a pH equal to 7. What we can see is the covalent sharing diagram of a water molecule. A water molecule can split up to form a H plus ion and an OH minus ion. We call the H plus ion the hydrogen ion and the OH minus ion the hydroxide ion. Because we have the same number of H plus and OH minus ions, the term we use to describe this is neutral. Neutral has a pH of exactly 7. When an acid and base or alkali reacts, we call this neutralization. This is because acids have a pH less than 7, bases or alkalis have a pH greater than 7, and when they combine together, they form a neutral substance which has a pH of equal to 7. That neutral substance that they always produce is water. So what is actually formed in a neutralization reaction? There are 3 word equations that we have to know, and these are based off of the bases song. Now remember, bases, they're so great, oxide, hydroxide and carbonate. The first equation that we're going to look at is an oxide base plus an acid will always produce salt plus water, water being our neutral substance. The second equation, we've got our hydroxide base plus an acid, which produces salt and water. These first 2 equations are the same. The third equation that we have to know is our carbonate base. We always produce salt plus water, but in this case we form a third product, which is carbon dioxide gas. So, how do we name a salt that's produced in a neutralization reaction? The first part of the name comes from the metal which is in the base name. Metals always lose electrons to form positive ions. What we've got here is we have got an ionic lattice structure because salts are ionic substances. The positive ion comes from the metal part and therefore the negative ion must come from the non-metal part. So the second part of the name comes from the non-metal in the acid name. Non-metals always gain electrons to form negative ions. So just like we always have a first name and a second name, there's some surnames that we have to know which are associated with particular acids. We've got hydrochloric acid and the surname of that salt would be chloride. If we had nitric acid, the surname of the salt would be nitrate, and sulfuric acid, the surname of the salt would be sulfate. So here's an example. If we take an oxide base, such as sodium oxide, react it with hydrochloric acid, we would produce sodium chloride. The first part of the name comes from the metal in the base, and the second part of the name comes from the surname of the salt, and we'd always form water. If we were to change the name of the acid, the surname would change. So if we've got sodium oxide plus nitric acid, the first part comes from the metal of the base, so the first part of the name will be sodium, and the surname of the acid would be nitrate, plus we'd always form water. This third example, we've got magnesium oxide reacting with sulfuric acid. So the name of the salt will be magnesium sulfate and we would produce water. Now I'm going to show you how to take the word equation and write the chemical equation. So what you might want to do is watch the previous lessons on SVSDF, writing formula and ionic formula. So if we take magnesium oxide and if we did our SVSDF, we would get the formula for magnesium oxide to be MgO. Sulfuric acid, we would get the formula for that to be H2SO4. And if we were to do the SVSDF for magnesium sulfate, we would get the formula as Mg(SO4). Water has the formula H2O. In this example, we have calcium hydroxide plus sulfuric acid. So the name of the salt will be calcium sulfate and we'll always produce water. So using SVSDF, we can get the formulas for each of the entities. Calcium hydroxide will be Ca(OH) twice. we'll have sulfuric acid, which is H2SO4. It will produce calcium sulfate, which is CaSO4, and will produce water, which is H2O. What we can see in this equation is we've got all the correct formula. We've taken it from a word equation to a chemical equation. And if you want to have a go at balancing these, you may wish to watch the balancing equations videos on basic, intermediate and advanced level. This last example is using a carbonate base. So we've got aluminium carbonate reacting with nitric acid to produce aluminium nitrate plus water plus carbon dioxide gas. Remember, carbonate bases always produce that third product. We would use SVSDF to get the formula for aluminium carbonate, which is Al2CO3 3 times with the 3 outside the bracket. We've got nitric acid, which is HNO3, reacting to produce the aluminium nitrate, which has the formula Al bracket NO3 close bracket 3, water, which has the formula H2O, and because carbon dioxide's got a prefix in its name, that's the di before the oxide, we just say what we see. So we do not use SVSDF, so the formula is CO2. If you need a little bit more practice at doing formula, you may wish to play some of the writing formula, your basic, intermediate and advanced, as well as your basic prefix formula. So if you want to pause the video, you can have a go at these 3 examples. You can have a go at writing the word equations for an oxide, hydroxide and carbonate base. And from there you may wish to practice your SVSDF to write out your chemical equations. These have not been balanced, but you may wish to watch the video based on balanced equations to have a go.